Section 1.6 Part B, one-to-one functions. Function is one-to-one. For every output, there is exactly one input. So remember our definition of just a function says that for every input, there's exactly one output. If it is a one-to-one function, that same relationship now has to be true in reverse. For every output, there is exactly one input. Remember when we tested for a function, we had a vertical line test, and we talked about how that vertical line, when we pass it over the graph, we're looking to see if that vertical line touches the graph in more than one spot, because the vertical line is representing all the different possible values of x, and we're checking to see if for any of those x's, it's touching in more than one spot. That would mean that it has more than one output and could not be a function. So now if we need to do this in reverse, and we want to know that every output has only one input, we can use a horizontal line test, where that horizontal line would represent all the different y values and making sure that there is only one x value that is producing each one of those y values. The reason that it's important to know or be able to identify one-to-one functions, because if a function is one-to-one, then we know it has an inverse. If a function is not one-to-one, then it does not have an inverse. So are these functions one-to-one? Looking at part A here. Is this function not one-to-one? No, it's not, because if I draw a horizontal line in here, at any point inside the parabola, I have two spots where that horizontal line is touching the graph. That cannot happen and it be a one-to-one function. And more importantly, not only is this not a one-to-one function, but that tells us then that this function does not have an inverse. Now, what you need to be careful of sometimes is they will give you a function like this, and let's say they give you the equation f of x equals x minus 1 squared minus 3. And then they tell you, well, we're going to restrict it to only looking at domain values greater than or equal to 1. So now if I come down here to our graph, and I'm only looking at domain values or x values greater than or equal to 1, so off to the right of that line, is that portion of the function one-to-one? The answer is yes. Okay, so you have to be careful. If they restrict the domain, don't just assume because you have a parabola that it's always not going to be one-to-one, because they may restrict the domain with something like this. Make sure that you're paying attention for that. Letter B. This function, is it one-to-one? Well, a lot of people would look at this and say, oh, no, it's not one-to-one. However, if you zoom in on that point, you would see that that is increasing very slowly. It never becomes horizontal. Okay, so this is a one-to-one function. So you have to be careful, especially when you're looking at graphs on the calculator. Remember, your calculator is doing the best job it can to give you the best graph it can do within the pixels of the screen and things like that. Okay, you need to recognize this as a cubic and know that this is increasing all the time. This is not a horizontal part of the graph. Therefore, it is one-to-one, which means that an inverse exists.